So this is lesson 4, our first day here, and we're trying to answer this question like, why is there blood in all places in the body? So last time we looked at MRIs and x-rays, and we saw that when we looked at the MRIs and the diagrams of the hand, the knee, and the foot, we saw nerves and blood vessels in each of those parts. And we're wondering if we would find blood in the body elsewhere, like any place that maybe we don't have blood, or is it all over the place? So this is a neat diagram. It's actually not a diagram. It's actually kind of made with a real body. What they did is they kind of injected like this plasticky type liquid into all the blood vessels of a volunteered body after somebody had died. And this is where you see all the blood vessels in the body. So anywhere there's red here, there's going to be a blood vessel there. So blood vessels are pretty much throughout the body. And we noticed like if you look in the leg here, you can kind of see through most of the leg. So we're wondering why there's not a lot of blood vessels down there. A lot in the head, a lot in the chest. The belly's kind of empty. We're thinking maybe, if people kind of add a little weight and they get a little fat, usually it's like in the belly area, so maybe we're thinking that because there's so much fat here, we wouldn't see a lot of blood in there. So that might be a possibility. So that's a pretty neat diagram, or again, not a diagram, but a pretty neat thing to look at to see where the blood is in somebody's body. So you can see the hand here, you got the arm coming down, chest, the whole head is covered with blood vessels, same with the feet. When we take blood samples from people, so perhaps you've had to go to the doctor and they took a blood sample, they put them in these little vials, and we're seeing that's on this side, it says blood just after it was drawn from a patient. So here's the vial of blood after they just took it out of somebody. And on the right hand side it says this one's been sitting for a couple hours. And we actually see like two parts here. So you got like a part that's kind of light and a part that's kind of dark. And what that kind of tells us is blood is not just one thing. If you let it sit for a while, it kind of separates out into two things. And it's kind of like salad dressing. So if you've had salad dressing in a restaurant or at home, you have to shake it after it sits for a while because the oil, and I think it's vinegar that's in it, separate out. So one of these is oil, one of these is a vinegar. I don't use salad dressing, so I'm not sure exactly what's in it. I know oil is in it. But they separate out, and if you wanted to use this, you have to shake it back up. If we go back one picture, so this picture of the salad dressing that's separated is kind of like this vial of blood here. Something has separated from the other part. If we shake up the salad dressing, it would be kind of like this. It's all one thing again. So question is, how can we figure out what's in blood? And some people in class were saying, well, we could use a microscope. We could run some tests on it, like a chemistry test, and find out what the blood's made of. We could, make a slide. We could use magnifying glass. So lots of things we could do to find out what's in blood. The first thing we're going to do is just review our microscopes, because we're going to be using our microscopes to look at some things. So we could use a magnifying glass for larger things. We could, glasses really aren't going to help, but magnifying glass might magnify something for us. What they're showing here is a magnifying glass is just one lens. Same thing with glasses, it's just one lens. But if we have a microscope, we're actually using two lenses. There's one by your eye and one down here. And what happens is when you magnify something with a lens and then you magnify that image, you're multiplying the effective multiplication or magnification of it. So for example, if we have a 10-time lens up on top, so this lens up here is just magnifying 10 times as much. And this is what we have in our class. So we have 10 times up here, and then there's 3 lenses down here. The red one is 4 times. So we have 4-time magnification here times the 10 times. So we have 40-time magnification. for the low power. The yellow one is a 10 time down here. So 10 times 10 gives us 100. So that's 100 times magnification. And the blue one, not the lens is blue, but there's a little blue band on it. The blue one is a 40 time magnification down here, times the 10 up here. That gives us 400 times magnification. One thing we did is we put some graph paper on the stage, this black part here, and we tried to find out how much of an area do we look at when we look through a microscope. And we found out when we look with the red lens, the low power, we see about 5 millimeters across when we look through the eyepiece. We're looking at about 5 millimeters across. When we move up to the yellow one, we're down to about 2 millimeters because we're zooming in more, so we're seeing less, but we're seeing it larger. So we're seeing about 2 millimeters across. And when we get to the blue one, the highest magnification, we're looking at about less than ½ of a millimeter across for the whole view when you're looking through it. Not the size of the object in the microscope, but just when you look in a microscope and you see the circle of light in there. That's how wide that circle of light is. It's 4 to 5 centimeters with the red one, about 2 with the yellow, and less than ½ with the blue one. We're going to be looking at blood tomorrow. So we're going to be looking at human blood. We're going to be looking at cat blood to see if there's any differences in size or color or shape. So we'll be looking at that tomorrow. So today we just kind of talked about these things, and that was it. So just watch the video and you're all set.